Hey everyone, welcome back to SN Dev. So today we'll learn how to create, train and predict with a simple regression neural network using TensorFlow and Keras. And we'll go step by step. So even if you are new to this machine learning and deep learning thing, you can follow along. Okay. So let's begin. So first the plan is, so here are the steps. So we'll first create some custom data for our regression. Then we'll build a simple neural network. Then we'll compile the model. Then we'll train the model. Then we'll use the trained model to make some prediction. Then we'll evaluate. Then we'll plot the model summary. Then we'll save the model so that you can use same model in multiple time. Then of course I'll show you how to load your saved model into again. Okay. So let's begin. First we need to create some custom data, right? So let's do it. Okay. So yeah, so if you are first time using TensorFlow, so you need to run this command pip install TensorFlow, and it will install all important TensorFlow and Keras libraries into your collab notebook. Okay, and after you have done that, then you simply need to import a couple of packages. So you need to import NumPy, also TensorFlow of course, and the alias would be TF. Then we'll be using TensorFlow with Keras, right? So we need to import Keras as well. Sorry. Keras dot models. Here import sequential. And why this sequential? Because we'll use sequential API of Keras to build our neural network. And okay, it's not import, it would be from. And next again from TensorFlow dot Keras layers, I'll import dense. And at last, to show our prediction graph, I'll import matplotlib dot pyplot as plt. Right? We don't need pandas because we are not doing this code with any data set. Okay, so let's run this, and it will take some time because it will connect with my device. So wait just a minute, you can fast forward this portion. Okay, it's done. Okay, I didn't connect with GPU, but you can, because I won't be training lots in lot of data, so it will be able to do it in my CPU. So then I have built a simple neural network. So here's okay. So as you said, create some custom data, right? So I need to do that first. So in our X, let me have some custom data. So line space minus 10, 10, 100. So I'll be taking 100 data points from minus 10 to 10. And you can take any other example for your use case. Then to evaluate my output, what I can do, let's say I'm writing this equation, right? 3 into x plus 7. This x will be in block. Okay. Now we better add some noise as well, just to get our proper model. So I'll be having a couple of noises from 0 to 2, like I'll be having 100 noises from 0 to 2, right? All right, now let's simply plot this. So scatter, I'll use x comma y, not this one. Then I'll label it as data points, then plt dot, now it will be x label let's say I wanna label it X, then again here Y label Y, then in legend, then simply plot dot show function. Let's run this, and yeah, you see, so this is our data points. Okay, the first step is done. Now our second step is we need to create a simple neural network, right? So let's create something. Okay, so what I should name it? Let's name it model, and I'll simply call my sequential function here. No, give it an enter, then I'll use a dense function, and let's say I'm creating this layer like this, ReLU. Like ReLU is an activation function, and my input shape would be 1 because I have only one X, like one input feature. So 1 comma, it would be like this. And what does that mean? This particular layer, this particular input layer means that it has only, like, this hidden layer have one neurons. Okay, that's, and then I need to give my output layer. This is also with one single neuron. Okay, and that's it. Why this error is coming? Okay, there will be one comma. Okay, now let me run this. So yeah, now we need to compile the model by defining a loss function, optimizer, and matrix. Let's do that. So now to compile this model, like for loss function I'll be using MSE, and for optimizer I'll be using Adam optimizer, and to evaluate the model I'll be using MAE matrix. Okay, like mean absolute error matrix. So the syntax will be simple: model dot compile. Here you need to define your loss. So for loss function I'll use MSE, comma, then for optimizer, right? Optimizer I'll be using Keras optimizers dot, I'll be using Adam optimizers, but you can also use like Sogatrix descent. Learning rate be 0.01. I'm giving it low. Then in matrix I'm giving it mean absolute error matrix. Okay, let's run this. Done. Now we need to train the model to find the data. For that, simply how we used to do in machine learning, history, in here model dot, we need to fit the data. So X comma Y, then for epoch, as of now I'm giving it 10. Okay, and for verbose I'm giving it 0 because I don't want to see any like too much outputs. But you know what, as per now let me keep it 1. Okay, so epoch 1, 2, 3, 4, 5, 6, 7, 9, 10. Here you'd see that the loss is decreasing, and the error and my MAE matrix is also decreasing. So it's somehow giving us a good sign that as per the training is happening, my loss is getting low. Okay, so this is some significance you should know. And then we have used the train model to make the prediction. So let's do the prediction, right? So for prediction, what we'll do, what we can do, let's first simply do some prediction. Let's say prediction model dot predict, right? And here let me do this one thing, array. I wanna try 7.0, right? And then I'll simply print this prediction. Let's see. Okay, so it's giving me minus 0.55. So should this be the answer? Let us check. So we have 7. So in this equation, if you put 7 in this x, so what's it giving us? So what's it giving us? 3 into 7, 21. So 21 plus 7, it should have given us like 28, but it has given us like in minus. So it's actually pretty like bad trained model. So now to improve the model, what we can simply do, we can increase these epochs. I want to train this model more and more and more. So in this time, I want to train this model like 10x. So let me do this. So it's done. So you'd see that the loss is become much less. So yeah, so now we got 3. So we are getting towards the good answer gradually. So now again, to get some more better answer, what you can do and what generally people do is that we increase more neurons in our hidden layers. So here what I would do, I'll simply give it here 10 neurons in my hidden layer. Okay, so let me run this. Now again do this. Now here, this variables mean how many output you want to see in here. Here you have 100 epochs. So I don't want this 100 training comes in my output. So for that, let me just keep it 0. Okay, and so it's actually training, but it's just not showing me. It's just simple. Then let us run it, and yeah, 28. See, it's much more accurate, right? So let's see the loss function actually. Like see the losses. At first we are getting in the loss of 300, 400 in this, but here we have the loss in 3.0 and the MAE in 1.5. So again, let me run this. So yeah, we got like pretty accurate value, right? So this is how you predict. And then also we should plot the prediction in a graph format as well, right? So for that, what we should do, ypred, you simply predict, call x, then I'll just do that because I've done it before. So plot.scatter xy, you are passing your xy data, then in plot xy ypred, then the color would be red, and the label would be model prediction. You are labeling x level, y level as x and y, then you are showing it. So here you see that the line have been very accurate. Okay, so this is what a simple regression neural network could look like. And now we have a couple of more steps to do. We have evaluation of the model, right? So let us do that now. So for that, okay, so for evaluation, right? Okay. So we need to import some more packages for that. So from sklearn dot matrix, I want to import mean squared error R2 score. Okay, then simply in MSE mean square error, I'll pass my y, and simply I'll pass my ypred, print MSE, then I need to calculate my R2 score matrix. So y swipe red, print R2. Okay, let me run this now. So get it, our MSE value is 3.8 and our model accuracy is around 0.98, mean you can say it as like 98%. Okay, then we have plot the model, and this means let us do that, plot the model, right? So for that, sorry, TensorFlow dot Keras dot utils import plot underscore model. Here in plot model, I want to simply pass my model value and show shapes true. TensorFlow Keras utils. Let me run this. Okay, so this is my neural network structure. Okay, my input shape, my output shape, my dense functions, all those things. Okay, and if you want to know the model summary, you can also write this dot summary like this. Just run this, and okay, this is not summary. Yeah, so this is my summary of my neural network models. Now I need to save the model, right? So to save the model dot simply save. Here, as per your name, I want to keep it model dot h5 because will keep it as HDF5 format, because this is the most like or easy one format or the more accessible format. While you run this, you'd have this h5 in your folder. Then let us load the model. So to load the model, what do? We'll simply use this loaded h5 model. Okay, then tf dot Keras dot models dot load model, simply dot h5. Let's run it. Okay, we need to pass some custom objects. Yeah, sure. So custom objects here, simply MSE tf dot Keras dot losses dot mean square error function. Let us run this first. Okay, now my model has been loaded. Okay, now you can use this model and now you can use this model for the prediction. So let me try this model. What I would do, prediction dot predict. What I want to predict? I want to predict this np dot array 7.0. Then again I'll simply print this. Okay, print, and see 27.938. so it's the same model, right? So yeah, thanks for watching, and yeah. Hello everyone, welcome back to the channel, and in today's video we'll see how to train a neural network for a binary classification task. Okay, so before jumping into the code, let's understand what's the classification of binary means. Okay, so simply put, binary classification predicts is one of the two possible outcomes, like spam or not spam for an email, and disease or non-disease for a medical diagnosis problems, right? So here is our data set. It will be, wait a minute, it will be CSV. Yeah, so the dataset that we have is around 1 lakh of rows, and the inputs features we have is age, income, and browsing results and browsing habits. And processing these three features, we have to predict that will the user would buy, like would the user will purchase something or not. Okay, and if it purchase, it gets at 1, and if it doesn't purchase, it gets a 0. Okay, so let's write the code now. So first we'll import our importer libraries. So I'm deleting this. Okay, so first we have NumPy, Panda, sequential API from TensorFlow Keras models, Dens from TensorFlow Keras layers, 10 test split for scikit-learn model selection, and standard scalar for scalar preprocessing, right? So I'm running this cell. Okay, and the next step is pre-processing the data, right? So let's begin. So here what we'll do, we'll simply load our CSV file first. So pd dot read CSV, and here I'll put my dataset dot CSV, right? And then simply data dot head 5 to check what the dataset we have. So we have age, income, browsing habits, and purchase. All right, now in X we'll have, let's say, age, and we had income, and we had browsing habits, and in Y we would have purchase, right? Then simply X dot head 5, and let's say for another one Y dot head. Okay, done. Now what we need to do, we need to split our data set into training set and testing set, right? So X train comma X test, Y train comma Y test is equals to train test split. Then we have to pass our parameters, so X comma Y, and test size I'll be giving 0.2, mean 20% for my testing set and 80% for my training set, right? And for random state I'm keeping at 42, simple. It would be underscore random state. Okay, all done. But there we need to do one thing, we need to standard scalar our dataset. So for that I'll call this standard scalar, and then I'll just simply scale my X train and Y train. So X train would be scalar dot fit transform to pass the variable X train. Right? Okay. So now it's time for, okay, it would be normal X. It's also normal X. And then we have our X test. Here also scalar dot transform X test, right? Let's run this cell now. Okay, so now comes the main part. We need to build our neural network. So here we'll build it. So I'll name it as model. I'll call the sequential API to sequential. Here I need to design my network, right? So I'll use dense function. In dense, I'll keep, for the input layer, I'll keep 16 neurons, and as activation function, I hope you know about activation function. So I'll be using ReLU for this, and as I said key, I'll be using this as my input layer, so I need to mention input shape. So in input shape, let's say for this case I'm keeping it will be X-train in this case. So the shape of this is, and simply okay, and I'll give one hidden layer just for the sake, dense. In hidden layer I'll keep 8 neuron, and as an activation function again I'll be using ReLU. That's the most best activation function that you can use. And for output layer we're using 1 neuron, and activation function for classification problem and mainly binary, we should always use sigmoid function. And why sigmoid function? Because sigmoid function always predict the value between 0 and 1, right? Because it gives you the value of the probability of between 0 and 1, so it helps. And we'll simply run this cell, and yeah, it will create me a neural network structure. Then we have compile the model. Here the process will be pretty simple. We need to simply use this compile keyword. Here I'll be using optimizer, and I'll be using Adam optimizer. Then for loss, as it is a binary classification, so I'll be using binary cross entropy, right? And for metrics, and these are the some basic parameters that we should use, and accuracy. So let's check loss, binary, cost, entropy, all the spelling is correct. Metrics, optimizer. All right, so let's run this. Done. Now we need to train the model. How are you gonna train the model? For train, in history variable I'll keep my training model. So model.fit, I'll simply pass the X-train and Y-train, right? And for validation data, I'll pass, okay, not here, here I'll pass X test and Y test, and epochs I'll be keeping 10, okay, and batch size I'll be keeping, let's say 32, and yeah, that's it. So let's run it, or what? Is it giving me any error? X-train, Y-train, I think it's pretty okay. Let's run this cell now. Yeah, so it will be giving me 10 epoch, so it will take some time. Okay, and by the way, yeah, if you want to like optimize your model more in the future, then you can play with this epochs and batch size variables, right? I mean, I have used 10 epochs, but in future you can use 50, 100, whatever as per your model. Okay, and then you can also play with this batch size. Then also you can use dropout layer, and dropout layers helps us so that our model doesn't get overfitted, right? So these are some basic things that you should be keep in your mind, but here I'm just showing you some basic structure of how to train a basic classification model using neural network. So yeah, and in future I'll be building more complex models, so there I'll be mentioning those processes. So yeah, it done. Okay, now our next part is evaluating the model. So for this, what we'll do, we'll simply calculate our loss, accuracy, model dot evaluate what I need to evaluate X test and Y test, right? And after doing that, I simply need to print this. So for print, I'll be using test accuracy into 100% to represent it in a percentage manner, right? Then simply I'll be using this, and yeah, so our model is performing at the rate of 90% accuracy. Now, as I said earlier, if you increase these epochs to 50 or 100, or if you in this layer, if you use like more hidden layers, more um, neurons per each and every layer, it will perform much better, right? So just some basic concepts, and for your experience and for your practice, I'll suggest you should use TensorFlow Playground. I mean, let me show you what it is. This is TensorFlow Playground, right? And if you are a beginner in this TensorFlow thing, then you should use all of this feature, and you should know that how those neurons works in the middle, right? So, and I'll show you in any of the next video in future. So yeah, that's it, and thanks for watching. And if you feel this video is helpful, so do like and subscribe. Hello everyone, welcome back to the channel, and today we are diving into the multi-class classification using the fashion MNIST dataset using TensorFlow and Keras. Okay, so first we need to import our packages, right? So let's import. And before that, what is multi-class classification? Where you have to predict like multiple class for the output, like by scanning an image, we might have to predict that is it a dog or a cat or a bird, right? This kind of prediction. And in this code, we'll be predicting that there will be a multiple images, and we have to predict that what kind of fashion fashion things is that. Okay, so first we need to import our packages. So for that we'll import TensorFlow STF, and from TensorFlow, as Keras comes with TensorFlow, so we need to import Keras from TensorFlow. Then we'll import NumPy as NP, then we'll import matplotlib dot pyplot as plt. Okay, then let's run this cell. Okay, then we have to load our data. Okay, so wait a minute. Okay, so fashion MNIST dataset comes with Keras library, so we just have to take that from Keras. So simply in a variable, I'll keep it, let's say fashion MNIST p from Keras dot datasets. I'll use fashion MNIST. Okay, and here I'll simply break it into train and test dataset, because as I said, this dataset is already comes with a pre-planned training and tested fashion. So x train, y train, and x test, y test. Then simply I'll load the data. Okay, so all right, we have loaded our data. Now it's time to visualize the dataset. So for that, and before visualizing, let's see what we have in our training and what we have in our testing. Okay, so for that we'll print xtrain dot shape and ytrain dot shape, and also let's see our test case. So x test dot shape and y test dot shape. Okay, let's run this both, and you'd see that we have 60,000 with 28x28 pixel size of X train and 10,000 images of 28x into 20x of images. Okay, and in prediction we have 60,000 prediction, and here we have 10,000 predictions. Now it's time to visualize the data. So for that, in this particular fashion MNIST set, we have around multiple classes, right, as we have discussed earlier. So in the class names, we'll name each and every classes. So we have t-shirt or top, we have trouser, we have pullover, we have dress, we have coat, we have it will be sandal, and of course shirt, and we have sneaker, bag, and ankle boot. Okay, now we need to plot these things. Let's say I'll use a figure size of how much, 10x10. Then I'll run a loop for I in range 25. Plot dot subplot, say 5 comma 5 comma with I plus 1 iteration with dot x ticks in an empty array, then y ticks also in an empty array. Then simply we have to plot in a grid, so grid false, and in plot I am sure we simply need to pass our train, and CMap will use binary x level class names. Here we need to pass our predicted values, right, like y train. After that simply we'll plot and show. Let's run this, and yeah, you'd see we have this many types of features. So we have ankle boot, t-shirts, dresses, pullover, sandals, then trousers, coat, bags, dresses, all those things. Okay, so now our next step would be process our data. So let's do it. For that, what do? And here the process means we have to normalize the data, because generally neural network works best when we normalize our data. Okay, so we will normalize here with divided all of those with 255. Okay, let's run this. So what it will do, it will convert our pixel value from 0 to 25, so from 0 to 255, and it will convert these values into 0 to 1 for our better training purposes. Now we need to build our model. For that, we'll write this model variable. Here in Keras, we'll use our sequential API. Then simply we need to create one by one the layers. So the input layers, we need to flatten our pixels. So we'll flatten, what will flatten? Our input shape of 28 and 28. Okay, then in the next step we'll create our hidden layer. So hidden layers dot, we'll use our dense function. We'll use 128 neurons with activation function. Of course, we'll be using ReLU. And for output, we'll use 10 neurons, and activation function will be using what activation function will be using softmax, because you should know that softmax is basically used for classification problems. Okay, now let's run our model. Okay, so I don't need this. So model is done. Now it's time to compile the model. To compile, our simple syntax would be model dot, we need to simply compile it. Compile, we need to mention our optimizer, right? So we'll be using Atom optimizer. Then for the loss I'll be using sparse categorical, because for the last one in the binary classification we have used binary coarse entropy, and here as we have multiple classes, so we have to use sparse categorical coarse entropy. And then after this we'll be using this matrix of accuracy. Okay, let's run this. Okay, there will be some error. It says okay, Atom. All right, now it's time to train our model. For train, we'll use simply the fit function. So model dot fit will pass xtrain comma ytrain. With epochs, I'll be giving it, let's say how much, let's say 20 epoch. With validation data, for validation purpose I have my tested data, right? So I'll give x test and y test, and let's run this. So it will run, and it will also show me the accuracy and loss as per each epoch. So it will train now. So till it's training, let me write my evaluation function, right? So in evaluation, what we can write, we have to figure out our test losses. So test loss and test accuracy. For that we'll use evaluate function. So evaluate will pass our test parameters x test and y test. Then simply we can print our accuracy. Okay, and it has done only 9 now, so just wait for a couple of seconds. So as per the 10 epoch, we have already reached 91% of accuracy. Okay, so let's wait if we can reach up to 95. All right, so we have finally reached up to 93% of accuracy. Okay, so let's print the accuracy here. So the accuracy is around 87 for the test, right? Because we are evaluating this in our testing. So you see 87% for the test results. Okay, now it's time to predict our code. So for that I'll use predictions variable. Here I'll simply call predict, right? Predict my x test, then I'll print this. I'll print, let's say, np dot argmax of argument max predictions. I'll do the first prediction. Okay, and then I also need to print the actual one. So x test 0. Okay, so we have 9 of actual test, and for the prediction we also have 9. So we have predicted all the test values. Now I need to plot it to show. So I am show use x test 0. We'll use a cmap and you'll use dot binary and then dot x level predicted class this, and also I need to use class names of at least y trends of 0th index. And then finally we simply need to plot dot show, and it will show us the predicted picture. So we are predicting with the ankle boot, and the predicted one is ankle boot, and it's actually an ankle boot. Okay, and that's it. We have successfully trained a deep learning model to classify a fashion MNIST images using TensorFlow. So if you have found this video helpful, don't forget to like and subscribe. And yeah, thanks for watching. Hello everyone, welcome back to SNDev. And in today's video we'll be seeing convolutional neural networks or CNN in TensorFlow. Okay, so before getting into the code, let us ask that what is CNN, right? So a CNN is a type of deep neural network designed for processing structured grid data like images, right? Because images are formed in pixels, and it's widely used in tasks like object detection, image classification, and medical image analysis. Okay, and the kind of what would say, like the key components of CNN would be like convolutional layers, pooling layers, and fully connected layers. So if I show you with a diagram, you would see that if this is the workflow of a CNN, so this is the image, like the input data that will be giving an RGB image. Then we have two layers. So one is convolutional layers that mainly extract the features from an image. Okay, then after extracting those features, those fade into an pooling layer with the consist of 2x2 stride. Okay, and what these strides mean, these strides reduce the spatial dimensions while retaining essential features, because in a, let's say in a 20x20 image pixel, not all the pixels are important, right? So we might have to extract the main pixel columns or the main pixel values from there. So that helps us by these pooling layers. Okay, so we have this convolutional 2D layer, then we have this max pooling layer. Then after all of this, we flatten all of these images, and then we fade this into an hidden layers with a ReLU function, and then from the output layer with a softmax we predict our output value. Okay, so this is the basic structure of our CNN. So, and in this problem we'll be solving an image classification using CIFAR10 dataset that contains more than 60,000 images across 10 different categories like airplanes, cars, birds, cats, and more. So our goal would be to train a CNN model to correctly classify these images using TensorFlow and Keras. Right? So let's begin. Okay. So first we have import necessary packages. Let's do it. So our packages would be TensorFlow HDF, then from TensorFlow you need to import Keras because Keras comes with TensorFlow, right? Then of course NumPy for basic mathematical, then to plot as PLT. Okay, now we need to load it. For load, what we will do in our, we'll load the dataset into X train, Y train. Okay, not here. right? So X train, Y train, X test, Y test, and here I'll need to load my data. So datasets dot ci far10 dot load data. Okay, then also I need, okay, let's run this cell first, then we'll be pre-processing it. So we have downloaded all data, right? Okay, now we need to pre-process. So for pre-process, we simply need to normalize the values, right? So for normalizing the values, what we'll be doing, we'll divide X train and Y test with 255. With 255, okay. All right, now it's time to build our CNN model. It will be pretty easy to build as we have shown in the diagram. So in model, I'll be naming my sequential. Here I need to build the model, right? So first Keras dot layers, then for the convolution layer we'll be using conv 2D, and we'll use 32, 3, 3. Activation, of course, we'll be using our ReLU, and in input shape, the input images should be with the pixel size of 32 into 32 into 3. Okay, then Keras dot layers dot max pooling with the stride of 2 into 2. 32, okay, it will be only 1 comma. All right, so what I'll be doing, I'll be just simply copy this 2 line and I'll paste it here. I'll be doing it with, let's say, 64. So 6433 activation function, but this is not an input layer, right? So I don't need this input shape, but for pooling I'll be using that. And again, for the last one I'll be simply using my convolution, but this time I'll be using with 128. Also I need to delete the input shape. Okay, now I'll be using that flatten layer. So layer dot Keras dot layers dot simply I need to flatten the data, then Keras dot layers dot for the hidden layers 128 neurons with the activation function of ReLU. Then for the output layers we have to use 10 neuron with activation function of softmax. All right, let's run the model. Okay, there will be some error. Keras layers max pooling. Acha, yeah, the max pooling have to be in the 2D form. So 2D. Okay, done. Right, now we need to compile the model. For compile, it will be as simple as other neural network syntaxes. So simply we need to compile. The compiling, we need to provide an optimizer. Let's say I'll be naming it Adam. After Adam, I need to provide it the loss. For loss, I'll be using sparse categorical because it has multiple category. So mask sparse categorical cross entropy. Okay. It's entropy, then matrix should be of accuracy. Let's run it. So we have compiled our model. Okay. Okay, now it's time to train our model. So for the training, we'll use this history variable. Here we'll call our model.fit function. .fit xtrain comma ytrain with epochs of 10, and for the validation data I'll be using xtest and ytest, and it will be, so let's run this. So it will take some time because it will run this whole model 10 times. So let us run it. Okay, it's using my GPU a bit now. Okay. Okay, so let's also write the function for the evaluation, right? For the evaluation, what we'll be doing will be our test losses and test accuracy, and we'll simply call our evaluate function, and we'll pass xtest and ytest with verbose of 2, and then at last I simply print that test accuracy is around test SCC. Okay, so now it as you see that our accuracy is touching around 80% for the training set and around 68% for the testing set, which is not really good because we haven't run it for the big epochs. We have only done for 10 epochs. We might have to run it for 20, 30, or we can just modify the structure a bit for a better result. So we are done with it. Now let's run this evaluation function. So you see the accuracy for the testing accuracy is 67%, which is of course not good at all. Now let's test the model, right? So for testing, we'll test onto some random data. So we'll create some pixel. So let's say randint 0 with xtest -1 prediction model dot predict np dot expand the dimension. Here I need to pass my xtest with that particular index value with axis of 0. Okay, then simply plot IM show. I need to pass that xtest with that index, then plot dot show, and for the final let's print the prediction label. The prediction label, let's say it would be prediction label, let's take it as np dot argmax. Here I'll call my prediction. Let's run it. So yeah, prediction level 8. So yeah, that's the thing. Of course it haven't really predicted properly, so you have it. Our CNN model successfully classified the image from the CIFAR dataset. So if you found this video helpful, like and subscribe. So yeah, thanks for watching.